Hi, can you hear me? Yeah? So I'm really excited to be here today because basically now it's 2 years since we were here in the same spot presenting our new data science platform called Data Science Experience. That was 2 years ago in 2016. I actually have the Spark Summit 2016 t-shirt here. That's what we got. And that's how we really got started with Spark at IBM, and we built a data science platform. And what I'm going to present you today is Watson Studio, which is kind of like the evolution of that platform. So I'm going to do like really 4 slides, and then I'm going to jump into a live demo. I would like to show you the product. So hopefully everything works fine. And it's going to be really quick. We only have 30 minutes. And at the end, there is some call to action on how to, you guys go and create an account. You can get started. And then we have a booth as well, so you can ask for a deep dive. So basically, the product that I'm going to present you today is Watson Studio, which is basically an AI platform. So we enable companies, we're really focusing on big enterprises, so they can create AI models and then put them into production. And we see 4 core areas where they struggle in order to do that. First is data. You already know data is residing in silos. It's very difficult to access. Data scientists, they don't get the right data in the form that they need. The next one is governance. Data is not secure. It's really hard also to put models into production and to manage their governance. And it's really hard as well to understand the lineage and understand the data and how it relates to machine learning models. Then skills. Skills are really hard to find today for data science. So the average time a data scientist will stay in a company is around 18 months. So there is a lot of churn, very difficult to retain a good data scientist in a company. So one of the core things is to get data scientists very productive from day one and enable them to share knowledge between team members. And finally, tools and infrastructure. Tools, it's kind of crazy how the machine and deep learning market is moving. We have new techniques, new libraries, new frameworks coming up every other week. So yesterday, Apple announced a couple of new exciting things with CreateML and CoreML too. So it is really hard to catch up. So what we're trying to do here with Watson Studio is bring the best of open source and build an open platform so everyone can bring their own tooling and start innovating that way. And we provide as well the infrastructure as a service in the cloud and the specific hardware that you need in order to accelerate the training of machine learning and deep learning models. So that's pretty much where we see companies struggling. So Watson Studio, and by the way, I'm the product manager. I've been leading the vision of Watson Studio. And what we're trying to do here is bringing everything that we think you guys need in order to put AI in a production environment. So that means bringing algorithms, all the techniques and all the tools to build and train machine learning models. All this conference, Sparks and AI Summit, is all about bringing data and AI together. So we are going to show you some of the data capabilities that we have. And then finally is a highly collaborative environment where we allow data scientists, application developers, subject matter experts, and data engineers to come in and all collaborate together in the same environment. So these are the 4 types of personas that we think will support in a company to inject AI in their business. We started with Mike, the data scientist. So Mike basically will come in, will train machine learning models, will set up the different algorithms, will play with the hyperparameters, and they will be used to program in Python, in R, and in Scala. Together with a data scientist, you always need a data engineer. So data engineer will be that person in the company that will set up the data pipelines, will schedule them, put them into production, and they will have this really good understanding on how everything works. They will be comfortable with Spark and Hadoop and HDFS. And basically, they are just getting the data ready for the data scientists to train those models. We added tooling for the domain expert. So normally, the domain expert, they don't have very advanced skills on data science or machine learning or deep learning, but they will actually understand if a model is performing well for a specific use case. So for that persona, we are including UIs so they can very quickly train models in a very guided way, and then also can test how those models perform in production. And finally, we have a long history in the Watson group targeting the application developer. So we've been providing APIs and SDKs to actually call Watson and get predictions. But right now, you can also train, a data scientist can train a model in their framework of choice, TensorFlow, Keras, Caffe, whatever they want, and they can put it into production, and the application developer will get clean API so they can actually integrate that in their business process or application. So the end-to-end AI workflow that we see is, we have it here summarized in 6 steps. The first 3 are more data-related. The last 3 are more on building models and putting those models into production. So let's start one by one. The first one is connecting and accessing data, and I'll show you this on the demo. But basically, we provide a set of data connectors in the cloud to IBM cloud data sources, to third-party data sources, AWS, Azure, and Google Cloud, and also to on-premise data sources. You can ingest a lot of data, structured and non-structured, and then in step number 2, we have a capability called the knowledge catalog, where this is a metadata catalog, and it's basically providing the capabilities to search and find that data. It's really hard to find data in a big enterprise, and we provide a user interface on top of that. So I'll demo that very quickly. And step number 3 is all about preparing data. That's where data scientists, they spend a lot of time. So I'll show you a couple of things, but the first one I would like to show you is data refinery, which is a user interface on top of Spark SQL. And basically what you do here is you create your ETL pipelines in a very straightforward way, and then you can put those pipelines into production. And if you need more flexibility, obviously we support open source libraries like Spark SQL directly on a notebook, or Pandas, or Dplyr. Then the last 3 items, the number 4 is really my favorite one. It's all about building and training machine and deep learning models. And for this, we support many different techniques, many different tools. I like to classify them in 3 buckets. The programmatic data scientists. So for those, we provide Jupyter notebooks, we provide R, Python, and Scala, we provide support for TensorFlow, Keras, scikit-learn, XGBoost, SparkML, all those frameworks. They can come in and use the one they want. And we also have a partnership with our studio, so we have it embedded there. Then we have more like data scientists that they don't want to code that much, but they are very strong on mathematics or statistics. So for those, we have like visual interface where you can actually train models, and we have auto modeling capabilities that will make recommendations on which algorithm you should be using for your specific use case. And the last one is really like the easiest one, where you, basically what you do is you retrain a pre-trained model. So you start already not from scratch, you start with a very smart model, and then you bring your own data on top of that, and you retrain it. So we have tooling here, and I'm going to demo that in a minute, which is basically to teach Watson with your own data. So you can fit that model to your specific use case. All that is combined with, as I mentioned before, with hardware specialized to accelerate the training. So we have a couple of things that are interesting. We have a partnership with NVIDIA, so we have the newest GPUs in the market available, K80s, V100s, and P100s, which are like the latest GPUs available for NVIDIA, are available as a service on the IBM cloud. And then you can also distribute that in parallels to accelerate the training. Number 5 is really where many companies struggle, is deployment of models and putting them into production. So for here, we also provide a lot of different options. We have, you can deploy as an online service, so you will get a REST API and you can call it. You can deploy as a Docker container and deploy that Docker container anywhere. You can deploy on edge devices, on IoT devices. And we actually announced yesterday our next integration with, hello? I lost, okay. We have a partnership with Apple, and then we announced our next integration with Apple Core ML. So basically, you can train a model with any of the frameworks supported by Core ML, and then very easily you can integrate those models in an iOS application. And in number 5 is not where the whole life cycle ends. Once you put that model into production, you need to take care of that model. You need to monitor how it performs, and that model will get updated, so you need to retrain it. So you have capabilities in the platform like feedback loop to automatically retrain and automatically redeploy the model and to track how that model is performing. And if something goes wrong, you can basically, you will get an alert, and you will interact with the data scientist so they can start working on it. So that's pretty much the workflow. I'm going to switch to a live demo. And it's going to be really quick, but hopefully you will get an idea. All right. So to get started, it's really simple. You just come ibm.co/watsonstudio or datascience.ibm.com, and you can create an account. And when you create an account, you will land in a page like this, where you basically have a lot of capabilities here. In this case, I have them all unlocked because I'm on an enterprise account. But it depends on your skills. You will have more or less features. So as I mentioned before, let's start with like how you connect to data and how you catalog that data. The first step is to connect to data, and let me switch here. I'm going to open one of the catalogs that I have. And you can understand a catalog as, I like to describe it as the Spotify for your data. Basically, you connect to one of the data connectors. You set up the connection to one of the data sources, sorry. And as I mentioned before, we have IBM services, we have third-party services, and once you set up that connection, you can enable something called auto-discovery. So basically, if you set up a connection with a S3 bucket, the auto-discovery is going to grab all the metadata from that bucket and will index it into our catalog. And we have the same for each of those data sources. Why do we do that? Because the idea is Spotify for your enterprise data, where you can very easily find that data. So that search is powered by that metadata. And I'm going to open one of the data sets here. Just to give you an example, this is a sample data set for insurance customer data. And when you click on it, you have a preview of that data set. And you can see, for example, that we have 2 columns that are anonymized. So what we're doing here is we're activating policies, and we're basically making the full data set available for a data scientist, but these 2 columns are anonymized, so they will never have access to the national ID and the credit card information. Normally, in any company, what they will do is they will never make this data set available to a data scientist, so they cannot use all this data for training. In this case, they will get it available. We're just anonymizing and applying policies. What we're also doing automatically is auto-profiling the data. So all the data that is in the catalog, we automatically profile, and we get some statistics from every field and column. And we do that for structured data, but also for non-structured. So if you have a picture, we'll have like all the tags, and we'll run visual recognition models to get metadata out of that data. And all this metadata is powering the search. So that's all to enable your data scientists to find and engage better with the data sets in the company. We have some social features as well, trying to make it more like engaging, so data scientists can like data sets, can add comments, and basically we understand how the people in the company is using the catalog to make recommendations. So you will get here good recommendations on data sets to use. So that's how you ingest data. The next thing that I wanted to show you is, let me switch here, is some of the collaboration features, right? So in order to put the AI in production, you need many different people to come in and work together as a team. So for that, we have this concept of a project. So in this case, this is a sample project that I have, where I have 161 assets. They can be data, they can be models, they can be Jupyter notebooks, and I have 28 collaborators. So I can add different people to the project with different levels of permission. Next will be all about cleaning data, right? So that's a tool called Data Refinery. So in this tool, this is built on top of Spark SQL. And basically what you do is you add different operations here. And as you are applying the different operations, you see how your data is being transformed. And as you are adding the operations, you are creating an ETL pipeline that then you can schedule and you can execute and share with other data engineers. This tool is also great for as an exploration tool. So imagine it's the first time you're using a new data set and you just want to get a preview. You're going to have a couple of visualizations. You have all that built in very quick. So that's one of the tools for data preparation. But then let me switch a little bit more on the AI, machine learning, and deep learning side, which I think is a little bit more exciting. The first one is really targeting data scientists that are really skilled and they really want a lot of flexibility. That means that they want to use their favorite open source libraries. So we provide this concept of environments that are predefined. So in this case, I'm showing you here an Anaconda environment with all the pre-installed libraries. But then you can also customize it. You can bring your libraries, you can install your libraries, and then these environments can be shared. This is really important. Like this, you have all the team working on the same environment, and there are no conflicts between libraries and management of those environments. So a lot of flexibility here. And then those environments can be used on top of different tools. One of them is, let me refresh. One of them is Jupyter Notebooks. So we have Jupyter Notebooks, and you can do Spark, Python, Scala, or R. And what you will see here is this is like the standard open source Jupyter Notebooks that I guess everyone is very, very familiar with. And then we have a set of features that are adding a little bit more interactivity and collaboration when you are working with Jupyter Notebooks. So for those that are not familiar with Jupyter Notebooks, basically Jupyter Notebooks are basically a document where you can add descriptions and you can type code in cells and then you will get the output directly there. And they are very, very good for collaboration to share the results between data scientists. So here you can have very, very quick access to all your data directly from a Jupyter Notebook. So you can create directly Pandas data frame or a Spark data frame if you're in a Spark notebook, and it's going to create the data frame directly in your notebook so you can start working with your data. You have comments here, so you can have a conversation with someone. You have version control directly built in Jupyter Notebooks. You can schedule your notebooks. You can share them or push them into GitHub. So trying to make it very, very interactive. Most of data scientists will spend a lot of time in this tool, working with TensorFlow, with scikit-learn. They will train those models. They will test them in this interface. And then once they are happy, they will just put them into production directly from this interface. I'm going to show you that in a minute. One thing I wanted to show you as well is, as I mentioned, we have a partnership with RStudio. So you have the full RStudio IDE embedded here. So let me move a little bit. I'll open this now in a minute. But let me move a little bit more into the Watson stuff that I think is also very, very interesting. So as I mentioned, Watson provides different services for speech, text, NLP, or visual recognition. In this case, I'm showing you here the visual recognition, which comes with 5 pre-trained models. A general model that is going to be very good and telling like very basic things like a car, distinguish a car from a truck, from a person, basic things. We have faces, which is good to detect the demographics of a person, age, sex, and stuff like that. Food recognition, explicit recognition, or text. What we are adding here now is the option to customize Watson, so you can retrain Watson with your own enterprise data. So basically, I'm going to show you an example here where we took a general model and then we created 5 custom classes here, and we used 346 custom images. So the idea here is to not only being able to detect a car versus a truck, but also to detect which type of car. So in this case, we want to be able to say what is a BMW versus a Volkswagen or a Volvo, or an SUV versus a convertible. So you bring all that data in, you create basically the different labels, and then and you do that in a user interface that is very straightforward and very simple to use. And once you create all these different classes, you basically hit train, and then you're retraining Watson. Once your model is trained, you will come to an interface similar to this one that I'm showing you, where you have like an overview. You can see who trained this model, if the model is ready, and basically you have an interface to test the model. So I can throw here test images or test in batch, and it's going to tell me the accuracy and how this is working. And then, as I mentioned before, for the application developer, we provide a set of code snippets in different languages to make it really, really simple to take this code and integrate it into an application. And regarding the core ML integration that I mentioned before, you can get all these models and integrate them directly into iOS devices. So that's some of the work that we are doing to transfer knowledge to Watson. So the pre-trained models of Watson are the most accurate already in the industry compared to all the competitors, and we have benchmarks that prove that. And imagine that you can now, on top of that, bring your own data and make them fit better your use case. Very, very powerful. I have 10 more minutes. So one thing that I want to show you here is what we call neural network modeler. So the challenge that we see here is that in order to be successful on deep learning, a lot of work comes into creating the good architecture of a neural network. So for that, we created an interface that this is not really targeting business users. This is really for deep learning engineers. And they will be able to go and play with the architecture and set it up the way they want. They have different options to set up the different layers and neurons in the neural network. And they do that in a drag and drop experience. And basically, this is an abstraction layer on top of the most popular frameworks like TensorFlow, Keras, Caffe, and PyTorch. And then when you click here, you will export the code automatically, and then you can start training directly from here. So this is really powerful. We hope people iterate a lot with this interface. Just to give you an example, every row in this interface, this is what is called a layer in your neural network. And some of the Watson models have 90 layers. So these architectures can get extremely complex. So that's why we provide a user interface to try to make it more straightforward. Also, a lot of work comes into customizing what we call the hyperparameters. So we have techniques to automatically find the best numbers to configure your neural network. This is also where a lot of data scientists spend a lot of hours today, and it's more like a trial and error. We provide a way to automate the process to better find the hyperparameters for your neural network. So once you do that, we have this concept called experiments, because what we believe is that data scientists, they don't train a model. They basically train hundreds of them. And they need to iterate, and they need to do it in an automatic fashion. So what we believe is that data scientists will come to work. They will design their neural networks. They will design how they expect the hyperparameters to be tuned. But then they hit the training. They can go have a nice evening and come back the day after. And all their models will be automatically trained. In this case, this is a very simple use case where you see only 2 models trained. But we've seen customers that they are training 200 models every night. They come in the day after, they see all the runs that are queued, they are in progress, that are completed. They can compare the runs, see which model performs better, which hyperparameters go better, and they can always come in here and add more training runs, select the hardware where they want to run. And this is also very important. The hardware will actually be connected on how fast you want to innovate in your company, how much you want to experiment, and basically by adding more powerful GPUs, you'll have to pay more money, but you will cut maybe the training time in half or more than half. So that's why specialized hardware for deep learning is becoming really important. So I know this was a very quick overview on Watson Studio. I have still 1 more minute, so I'm going to show you how you actually put those models into production, which is something that I mentioned as well. So all your trained models will show up here in a section called models, and you can come and take one of them, for example, this one. And for every model, you have a lot of information about that model, who trained it, what time, which framework. In this case, this was trained using Spark, and we're using 60% for training, 20% for testing. You have a lot of information around the notebook, the schema, and when you deploy it, you have different options to deploy it. You can deploy as a web service, batch, or real time. So that's how you will put the model into production just in 1 click. And then you can set up what we call performance monitoring, where you basically track how that model is performing in production and automate the retraining of the model. So we want to provide you a lot of automation, but also a lot of control and monitoring options so you can understand how that AI performs in a production environment. So let me switch to the slides to close. All right, so that was the demo. This is a good chart on a summary of some of the things that I showed you today, right? Watson Studio, there are basically three layers. There is the tooling on the top, with open source tools like Jupyter Notebooks and RStudio. We have our own IBM tools like SPSS, Data Refinery, and the Watson APIs. On the second layer, on the middle layer, we provide the most popular machine and deep learning frameworks. And as new ones are becoming popular in the industry, we're going to integrate them. And then this is all in the IBM cloud. So it's all based on containers, Docker, and Kubernetes. And then we have a specialized hardware, as I mentioned. If you have any questions, we have a booth downstairs, so we can explain you that. We have at IBM, we have a ton of sessions here at Spark Summit. Some of them are really about how to put Spark ML pipelines into production. We have some interesting ones as well about deep learning and accelerate on GPUs. And then I encourage as well to go to ibm.co/WatsonStudio, create an account, and give it a try. Okay? All right, thank you.